Um, let's talk about the acids and bases, basics grade 11. So first, let's just talk about the strong acids and the strong base that you must expect. So let's start with the strong acids. So I'm gonna list all of them, the strong acids. So we have the strong acids and we have the other acids. So if the acid is not strong, that means it is a weak acid. If the base is not strong, it means that it is a weak base. So the list of the strong acids, acid number 1, let's talk about HCl. So HCl is a formula, and then the name, it is hydrochloric acid. Hydrochloric acid. So you must know the formula and the name. So maybe sometimes they will ask you to write the formula or the name. So the formula is HCl, the name is hydrochloric acid. And now, since we're going to talk about Lowry-Brønsted theory, Lowry-Brønsted theory, it says acid is a proton donor. So it donates hydrogen. So since this one, it has only one hydrogen, it means that it's going to donate one hydrogen, or it's going to give one hydrogen away. So since it's going to give one hydrogen away, it means that we're going to say this one is a monoprotic. So it is a monoprotic acid. Mono means one. So it means that this one is going to give one hydrogen away. And then let's talk about acid number 2. Acid number 2, HNO3. So this one, the name is nitric acid. So nitric acid is also giving one hydrogen away. It means that it is also a monoprotic acid. So let's talk about acid number 3. Acid number 3, H2SO4. So this is a sulfuric acid. So sulfuric acid is giving 2 hydrogens away. So it means that since it's giving 2 hydrogens away, this one, it is diprotic, di for 2. So it's giving 2 hydrogens away. So it is diprotic. And then the last one, H3PO4. So the name of this one, it is a phosphoric acid. So let's check. Phosphoric acid is giving how many hydrogens away? It's giving 3 hydrogens away. So it means that a phosphoric acid, it is a triprotic. It is a triprotic acid because it's giving 3 hydrogens away. So why are we saying these acids are strong acids? So when we talk about the weak acid and a strong acid, we're going to talk about how we define, in fact. When we define the strong acid, it ionizes completely in water to form hydrogen ion or hydronium ion. So the strong acids, they form H3O plus or H plus. So when they ionize completely in water, they form hydrogen ion or hydronium ion. So if you can check, there is hydrogen here. So it means that it's either they're going to form hydrogen ion or hydronium ion. So that's why we consider them as strong acids. Now let's move to strong bases. So strong base, So strong bases, a base number 1, NaOH. So the name for this one, it is a sodium hydroxide. We have sodium hydroxide. That is a strong base number 1. A strong base number 2, this one is KOH. So KOH, it is a potassium hydroxide. Potassium hydroxide. And then a strong base number 3, it is LiOH. As you can see, all of them, they have OH. So this one, it is lithium hydroxide. This one is lithium hydroxide. So remember to know the formula and the name. So the last one, we can talk about the BrOH2. So this one, it is barium hydroxide. So why are we saying this is a strong base? A strong base, it ionizes completely in water to form the hydronium ion. So when a strong base ionizes completely in water, it's going to form OH minus. So that is hydronium ion. So as you can see, for example, we have NaOH. So when it ionizes in water, it's going to form Na plus OH minus. So when it ionizes completely in water, it forms the higher concentration of hydronium ion. Yes, like that. So without the waste of time, let's go straight to I want us to talk about the Lowry-Brønsted theory for now, and then on the next video we'll talk about Arrhenius theory. So acid and base, we define them in 2 ways. So the first way, it is Lowry-Brønsted. And we have Lowry-Brønsted theory. So Lowry-Brønsted theory, we have acid, we also have base. So in Lowry-Brønsted theory, according to Lowry-Brønsted theory, or in terms of Lowry-Brønsted theory, acid, it is a proton donor. Base, it is a proton acceptor. So why a proton donor? Because it donates hydrogen, or it gives away hydrogen, and then a base is going to accept that hydrogen. So that's why we call it a proton acceptor. So now, for example, we have this equation, HCl plus NH3. And then let's check now. HCl, it is an acid. NH3, ammonia, it is a base. So now an acid reacting with the base, we are going to have now this hydrogen. This one, since it's an acid, acid is a proton donor. It means that this one is going to give the hydrogen away. So it's going to give the hydrogen away. It means that this one is going to accept that hydrogen. So that's why we call it a proton acceptor. So since this one is accepting the hydrogen, now we're going to have NH instead of 3. Now we have 4 plus, because it's gaining, or it accepted the hydrogen, then plus. Since this one, it lost a hydrogen, or it gave the hydrogen away, now we're going to be left with Cl minus. So if you can check, this one, it was an acid. This one, it was a base. So this side, now we have a base here, we have an acid here, and then here we have a base. So ammonium, it is an acid. Ammonia, it is a base. So this side, it was an acid, this side, it became a base, just like that. So let's check another one. This one was number 1. Let's check. Let's say we have number 2. So we can say H2SO4 plus H2O, it gives us. So let's check. Sulfuric acid, it is an acid, and it is a strong acid. Water, it acts as a base. So since water is acting as a base, so let's say this one, it is an acid, and then this one, it is a base. So an acid is going to donate the hydrogen, and then the base is going to accept the hydrogen. So since this one's going to accept the hydrogen, now it's going to be H3O. Instead of 2, it accepted 1 hydrogen. So it is H3O plus, then plus. Since this one, it lost 1 hydrogen, or it gave 1 hydrogen away. So now we're going to be left with HSO4 minus. So now this one, it become an acid. This one, it become a base. So before I forget, we have this one, what you call an ampholyte. So an ampholyte, it is a substance that can either act as acid or base. So make sure you get that correct. It either act as acid or base, not acid and base. Acid or base. So that is an ampholyte. It means that this substance, it can act as an acid. It can also act as a base, just like that. So we call it an ampholyte. So let's say now we have the questions. The first question. Now let's check the first question. They said define an acid in terms of Lowry-Brønsted theory. So I'm just going to write here. Number 1 as an answer, or answers. Let me say answers. So number 1, define an acid in terms of Lowry-Brønsted. So according to Lowry-Brønsted, acid is a proton donor. It is a proton donor. That is your 2 marks. So it is 2 marks. So just say it is a proton donor, and then you get your 2 marks. Then let's check number 2. Consider the following acid-base reaction. So before let's go back. Before we answer these questions, I want us to go back. I forgot something. So here, since we have an acid and base, so we have what you call a conjugate, or let me open a new page. HCl plus NH3, and then it gives us NH4 plus and plus Cl minus. So we have what you call a conjugate. Let me see, a conjugate acid base. So a conjugate acid base, since we say this one, it is an acid, you check. This one, it is a base. This side, this one, it became an acid since it accepted the hydrogen, and then this one, it became a base. So once we say this one is a conjugate base acid of this one, or this one is a conjugate base pair of this one, we are saying, let's check now. This one, it was an acid, it accepted the hydrogen, and then it became it was a base, it accepted the hydrogen, and then it became an acid. So this one is a conjugate pair of this one. So these ones are conjugate pair. It's a conjugate pair because it was a base, it became an acid. This one, it was an acid, it became a base. So even this one is also a conjugate pair. Just like that. So we can also try another one. H2SO4 plus H2O, and then it gave us H3O plus, then plus HSO4 minus. So this one, it was an acid as a sulfuric acid, and then this water, it was a base. And then the water, since it accepted the hydrogen, it became an acid this side. And then this one, it became a base after giving the hydrogen away. So now let's check. This one, it was a base, it became an acid. So this one is a conjugate pair of this one. So it is a conjugate pair. These one are conjugate pairs. So this one was an acid, it became a base, it's a conjugate pair of this one. So these ones are conjugate pairs. Just like that. That's how it works. So now we can go back to our questions. This is what I wanted to explain. Okay. So the first one, they said define an acid in terms of Lowry-Brønsted. So we did define. We said acid is a proton donor. That's for 2 marks. And then number 2, consider the following acid-base reactions. So we have this one reacting with the this one to give us this one plus this one. So let's check. Ammonia, it is a base. It will always be a base. And then this one, it is an acid. So let's check. How do we say that? This one was having 3 hydrogens. Now it's having 4. It means that it accepted the hydrogen, or it accepted the proton. This one, it was having 2 hydrogens. Now it's having 1. It means that it gave the hydrogen away. So this is what we must do. You just do this. This one, it is an acid, and then this one, it is a base. Just write this in an exam. Then it will be easy. So since it gave 1 hydrogen away, it became a base, and then this one became an acid. So 2.1, identify the conjugate acid base pairs in the above reaction. So it's 4 marks. So we just identify the acid base pairs in the reaction above. So now this one was an acid, it became a base. It means that this one is a conjugate pair of this one. So just do this, a conjugate pair of this one. So this one was a base, it became an acid. So this one is a conjugate pair of that one. So now number 2, 2.1. Since they said we must identify the conjugate pairs, now we're going to say H, since it's 4 marks, H2PO4 minus, and since they move together, and what? HPO4 2 minus. So it was this one and then it became this one. It was an acid, it became a base. So this one, it was a base, it became an acid. That means it's a conjugate pair of that one. So it's NH3 and H4 plus. So it was a base, it became an acid. Just like that. So, okay, I'll just use this base for number 2.2 and 2.3. So 2.2, they said define the term ampholyte. So I just said ampholyte, it is a substance. So let's say it is a substance that can act as either acid or base. So an ampholyte is just a substance that can act as either acid or base. So be careful here, acid or base, not acid and base, because some other learners they confuse the two. So now 2.3, choose an ampholyte in the above reaction. You just choose an ampholyte in the above reaction. So now let's check. This one, it is an acid, it became a base. Just like that. But we can also use this base as an acid. This one is a base, we can never use it as an acid, it's always a base. And ammonium ion is an acid, we can never use ammonium as base. So it means that this one we can also use it as a base or an acid. So we're going to say HpO4 2-, it is our ampholyte. So let's move to the next question fast. So here is the next question. You can pause the video and try it out if you can. When sulfuric acid reacts with water, it ionizes in 2 steps, as shown in the 2 balanced equations below. So there is equation 1, that is sulfuric acid reacting with water, and then this what I was talking about. Now this one, it became a base, but this side it acts as an acid. So just do this. This one is an acid, the sulfuric acid. So you just write acid. Here you write base to simplify life. So this one was a base, it accepted the hydrogen, it became an acid. And then since it lost the hydrogen, this one, it became a base. Now let's check reaction number 2. Reaction number 2, this one, it was 2 and then became 3. It means that it accepted the hydrogen. So since it accepted the hydrogen, first it was a base, and then last it was an acid. It became an acid, So it means that this one, it is an acid, and then it became a base. So the left hand side you have acid base, the right hand side acid base, just like that. So now, before we answer the questions, already we see an ampholyte. Let's check. HSO4-, it was a base. Now the same HSO4-, it is an acid now. You see, it is an ampholyte. This is our ampholyte. So define an acid in terms of Lowry-Brønsted theory. So let me just write here. This one, it is a proton donor. So a proton donor, that is the 2 marks. And number 2, write down the formula of the conjugate base of the conjugate base. Once they say the conjugate base, it means that this one is acting as an acid. So we are looking for the conjugate base. Since this one is an acid, so since here this one we are looking for the conjugate base of this one. It means that this one is an acid now. So you check in which equation or in which reaction this one is acting as an acid. So you are looking for its conjugate base. So reaction number 2, you see HSO4. HSO4, it is an acid. So the conjugate base of this one is what? Since it was an acid, it became a base since it gave the hydrogen away. So the conjugate base of this one, since it is an acid, is what? I'll write here, SO4 2-. That is the conjugate base of HSO4-. Just like that. 2.2, you write down the formula of the conjugate acid of the same one. So since they are looking for the conjugate acid, it means that this one, it is a base. So they are looking for its conjugate acid. So you check where in the reaction this one is acting as a base. So you check this one, HSO4, it is a base. So its conjugate acid is what? Is H2SO4, because we must move like that, acid base. So the conjugate acid of this one is H2SO4, just like that. So this one, this is what we're going to do. I forgot. So this one, conjugate pair is this one. This one, the conjugate pair is that one. Same. This one, the conjugate pair is this one. This one, the conjugate pair is that one. So maybe it will be easy for you to do that. The last question, a substance that, write down the formula of the substance that acts as an ampholyte in these reactions. So we are checking for those two reactions. There is only one substance that is acting as an ampholyte. It is a base that side. This side it is an acid. So already I've talked about it. HSO4, it is a base. HSO4, it is an acid. So it means that is our ampholyte. So we're going to say this is HSO4-. So this is our ampholyte, because in reaction number 1, it acting as a base. In reaction number 2, it acting as an acid. So I think that's it for now. Thank you, and please don't forget to subscribe.